In class, you explored the relationship between length, area, and volume when you're given a particular scale factor. And what you found was that when you're given a scale factor r, that for length, you simply multiply by r. But for area, because you are increasing 2 dimensions, that's area, by r, you're actually increasing the full area by r squared. And for volume, you're increasing 3 dimensions by r, so that means you're increasing the original volume by r cubed. So let's look at a couple examples. In the most left-hand column, we're looking at the scale factor, we're looking at the r. In the middle column, we're looking at some originals, so original perimeter or area or volume. And then in the last column, we're going to actually calculate the scaled length, area, or volume. So the first thing we have to ask ourselves is, in this case, it's perimeter, but we didn't list perimeter up here as one of our 3 options. So we have to, translate that. And perimeter turns out to be a length. And one way to recognize this is that there's no squared on my units. My units are just units. So my scaled perimeter is going to be r times my original perimeter. So in this case, my r is 3, and my original perimeter is 16 feet, which gives me 48 feet. My next example is a volume. And for volume, that means that I have taken the 3 parts of the volume and I have increased each of them by a scale factor of 2. So my scaled volume is going to be r cubed times my original volume. So r is 2 cubed times 86 inches cubed. So I've got 8 times 86, which is 688 inches cubed. Our next example is area. So we say our scaled area is r squared times our original area. As r squared, we're increasing the length of 2 in a 2-dimensional figure by a particular r scale factor. So in this case, our scale factor is 1/2. So I've got 1/2 squared times our original volume is 24 pi centimeters squared. 1/2 squared is 1/4. And when I multiply that by 24 pi, it's the same as dividing by 4, so I end up with 6 pi centimeters squared. Our last example is an example where I would need to pull out a calculator in order to find the answer. It wouldn't be something that I would simply know the multiplication off the top of my head. And that's because the r is a decimal. So I'm going to say the scaled volume, again we're doing volume, which means 3 dimensions have been increased by a scale factor of r, so that's r cubed, times the original volume. Our r is 2.4, 2.4 cubed, and our original volume is 85 pi meters cubed. So I'm going to plug into my calculator 2.4 to the 3rd power, and I'm going to multiply that with 85. So normally you wouldn't have a decimal with pi, but in case that you're curious about that, we could say that our scaled volume is exactly 1,175 and 4/100 pi meters cubed. Or we could find an approximate by multiplying that answer times pi, which would give us approximately 3,691.50 meters cubed.